Hi everyone, welcome to this project. In this project, we are going to be deploying an e-voting application to Amazon EC2 instance. Now, this is the flow of the application and how the application works. So it is a microservice architecture, and we have a voting app, and also we've got a result application, and also we've got the net worker, which is like the worker that does the processing, and also we've got two databases. We've got Elastic Cache, which is Redis, and also we've got AWS RDS. And the flow of execution is when a user casts their vote, the vote is sent into a queue, Redis queue essentially. It's sent into a Redis queue, and then from the Redis queue, there's a worker application that pulls stuff from the queue, processes it, and then stores it in the database. Now, when user goes to the result application to query the application, they simply, under the hood, query the database, which in turn returns the vote to the user. And in order for us to deploy this securely in production grade, we need to create a network, a VPC in AWS. So this is how the VPC design is going to look like. So we're going to be creating our own virtual private cloud in AWS, and also we're going to split it into different subnets and subnet groups. And for that, we need to create nice subnets. So we've got the first one, we've got private and the public subnet. So we've got 3 subnets for the database, which is, as you can see here, and also we've got 3 private subnets for the application tier. This can be the worker, it can be the result, it can be the result, it can be the vote application. And also we've got public subnets, which are here, which are the ones denoted by the green field. And also we're going to be deploying NAT gateway in the public subnet to enable our instances in the private subnet to communicate with the internet. We need this because we are going to be cloning some repository into those private instances and then installing some packages. And if we don't have NAT gateway that will grant us access to the internet, then that is not possible. And then we've got a router, which is going to routing all the traffic, directing all the traffic, but this is abstracted to us by AWS. It's abstracted from us from AWS. So we are not going to be using this. We are not going to be configuring this, but under the hood, that is what happened. And lastly, we're going to be attaching an internet gateway to the VPC. Now, this will now in turn grant access from our VPC down to the entire, internet. And this is the flow of execution. So when a user query the DNS name, Route 53 is going to resolve that DNS name to the load balancer. And the load balancer is going to be an application load balancer. So if, let's say the DNS name is 𝗪𝗿.com, and when the user query 𝗪𝗿.com / by default is going to route to the result application, which is going to route to the result application. However, if it queries /vote, then it's going to route to the voting application. So it's going to be an application load balancer because it works at layer 7, so it understands routing based on paths, headers, and all of those. So this is how the architecture is going to look like. So let's go through it one more time. This is the application, how the application is going to work in a nutshell. And also, this is how we are going to design a VPC with different subnet and CIDR blocks. And also, this is how the flow of execution is going to look like. So without wasting much time, let's jump straight into it. Now let's go over to the flow of execution. Now this is how the flow of execution is going to work. The first thing we need to do is to create a VPC, and we're going to have 3 public subnets, 3 private subnets, and 3 database subnets. Then after that, we are going to create security groups for the services and assign specific IAM permissions. Now we're going to create security groups and then assign permissions, IAM roles. Then after that, we need to create 5 EC2 instances for the 5 microservices. For this particular project, we are going to be deploying the Redis and the Postgres using containers. We're not going to be using RDS and Elastic Cache. However, as we move forward to re-architect this project to add more functionalities like auto-scaling groups and etc., then we are going to include AWS native services like Redis and Postgres, which is AWS RDS. So we're going to create 5 EC2 instances. The result and the vote will be on the public subnet, while the worker app, Postgres, and Redis will be on a private subnet. This will be bootstrapped using the user data script. So we can use the user data script to bootstrap this. Then after that, we are going to create a separate instance, which is called a bastion host. This bastion host will grant us access to the private servers running on the private subnet. Remember, when you have an EC2 instance running on the private subnet, you can't log in directly from your local machine to that server. So you need a bastion host where you need to log in, and from there you can have access to those to those servers running on a private subnet. Then after that, we're going to log in into each of those servers, and then change the host name to match the specific service. For instance, if it is if that server is for voting application, we can change the host name to vote. Then once we've done that, we are going to clone the repository and add Docker Compose file along with the required environmental variables. So after that, we clone the project repository and then create a Docker Compose file for that specific service. Then we'll create private hosted zone in Route 53 to map service names to private IPs for Redis and Postgres. We're going to create private hosted zone as well. Then once we've done that, we've added our environmental variables in .env file. Then we can add run Docker Compose and then verify the vote. So that is the flow of execution. And once again, we can see the architectural diagram. This is the application. This is the 𝗪PC design, which is our own private network. And also this is the application design. And this is exactly what we're going to be doing. Now, without wasting much time, let's jump into the AWS console and start performing some magic. So let me go to my AWS account. This is my AWS account. And from here, the first thing we need to do is to create a 𝗪PC. So we're going to create it manually. So we'll come here and click on create 𝗪PC. Now, there are so many ways, there are various ways you can create 𝗪PC. You can use Terraform, you can use the console. And if you are using the console, you're going to have some you can configure it manually, and also you can also use the wizard, which is going to auto create everything for you like this, basically. And then if we come here, this gives you more control. So you need to create each and every component all by yourself by making some customization, right? And also if you are using Terraform does it really good with just by using Terraform module. But in this project, I'm going to be showing you how to deploy all of this using the console manually. Then after that, we can now start thinking about how to automate everything using Terraform and then using Ansible to install those Docker and Docker Compose. So let's jump straight into it. So in order for me to be very fast and also to make it easy, right, let's use the 𝗪PC wizard. So here we're going to create a name for the 𝗪PC. So here I'm going to call it eVoting 𝗪PC. Then scroll down. Then we're going to specify a CIDR block range here. From here, if we go back to our 𝗪PC design, let's look for the 𝗪PC CIDR block for our 𝗪PC. So the CIDR block is 10.6. You can see it here, 10.6.0.0/16. So let's get that. So 10.16.0.0/16. That's good. And you can see the available IP address, which is 65,536 IP address. That's a lot. And we need more. We need lesser than that, even because we've got just few services. So let's scroll down. IPv6 CIDR block, yes, and default tenant, select that as default. And the AZs, we need 3 AZs, 3 public subnets, number of private subnets. Obviously, we need 6 private subnets, but let's just leave it 3 for this project. We're going to, like I said earlier, we're going to be re-architecting it, and what you see on that architectural diagram might not be the final or the exact architectural diagram, but that's just like a heads up, like an overview of how we want to do it. We need one NAT gateway in one AZ, and also we don't need S3 gateway. Let's set that to none. So let's go over the configuration again. So we specify the e-voting application, specify our CIDR block, and also we specify 3 subnet, 3 private subnet, 3 public subnet. And also for the NAT gateway, we need one NAT gateway. NAT gateway are quite expensive, so we're going to be using one in just one AZ. And also we don't need that. Then we are going to enable DNS hostname and DNS resolution. So let's just leave that and then click on create VPC. Now when you do that, this is going to take time, right? If you click on create VPC, it's going to take some time, some few minutes. And the one that's going to take our time is when it tries to create the NAT gateway. NAT gateway takes a few minutes to get provisioned. So while we are waiting for that, let's head over to EC2 to create the security groups for the various services. So let's come to the security groups and let's come to the security group and create new security groups for our service. So we're going to come to security groups and say create security group. The first one I'm going to create is, let's create for the backend service. Let's call it backend service, and then let's give it a name, allow connection from front end apps. And then the VPC, we're going to specify the one we created. The one we created is called e-voting, so we're going to select that one. Then for the inbound rules, you can scroll down to the inbound rules, the traffic we are allowing. First of all, we need SSH access. This is outbound, delete that. We need inbound. We need SSH access from CIDR blocks within the VPC, right? Because if we don't specify this, we can't access it. So we need SSH access from the jump host. But for now, let's just leave that because we haven't provisioned the bursting host, so we're going to leave that as it is. And let's say all traffic, right, from okay, we've not created security groups for the other front-end service, so we cannot specify their security groups here. So I think let's rename this to, let's call this the front-end applications. Let's call it the front-end security groups. And then allow connection. Let's say allow connection. Let's just say allow connection, or let's call it SG for the front end. And then leave the VPC as it is. And for that, for the 2 front-end application, we need to be able to connect from them, like right from the internet. User can access them. So we can just say port 80 only, since we are not using HTTPS. Let's just use custom TCP and change it to port 80. And then from any IPv4, and this is allow access from users. And then we also need SSH access to it. Now let's say from my IP, I'm going to say from my IP. And 𝗟𝗲 SSH from DevOps engineers, like this. So those are the two access we need to be able to access this application. And remember, the application is going to be deployed as a Docker container. So once we've done that, the application is going to be exposed using a specific port. Then we can now come here and add that port, right? We'll now come here and add that port. So these are the two basic rules that we need to add. So let's add rule. Sorry, let's click on save rule. We don't need the last one, so let's delete that. So create security groups. Now let's create another security groups again. Another security group. Front end. We can rename this to be front end security groups. Now let's create another one. Let's call this one the back end SG, and then SG for Postgres and Redis. The VPC, we're going to specify e-voting VPC, and then let's say allow all traffic from the security group. From the security group? From the front end security group, right? So we want all traffic from the front end to be able to communicate with the backend service. Now, in an ideal situation, in the real world, you shouldn't be granted this kind of access, right? You need to be specifying like fine-grained access by using the least privilege principle. But for this demo, I'm just doing it like this, just for a disclaimer, right? So let's do that, and then let's create security groups. So once we've done that, let's go back to the flow of execution. We've created the VPC, we've created the security group. The next thing for us to do is to now launch the 5 EC2 instance. But before then, we want to be able to bootstrap as we provision all the servers, we want to be able to bootstrap it by installing Docker on it. So we don't need to manually log into all those machines and start installing Docker one after the other, right? So before we do that, let's go over to this and look for how to install Docker. How to install Docker on Ubuntu. Forgive my my typos. So let's come here and search for how to install Docker on Ubuntu, because we're going to be spinning up Ubuntu instance. As you can see, this is how we can do that. And in order for this to work, we need to put this into a bash script, right? Because if we don't do this, we can't manually run all these commands just like this. We need to be able to put it into, pass it into bash script. So let's do that. So let's head over to the create EC2 instance, and then go to instances like this, and then click on launch instance. So the first one, being that we are launching 5, we are launching 3 in a public subnet and 2 in the private subnet, we can't launch all the 5 at once, because when you create an EC2 instance, it gets attached to a subnet and availability zones, and you can change that once the instance is up and running. So we're just going to provision 1 for the 3 front ends. Not the 3 front ends, but I just want to put them in the public subnet, right? And put the database and the Redis on a private subnet. So let's do that. So let's call this front end. Remember, we're going to change the name once we have all the 3 instances running. So let's call it front end. And we're going to be using Ubuntu as the operating system. Let's change that to 3 for the 3 application. And let's stick with T3 micro, which is within the free tier eligibility. So we don't want to get charged. And also for the key pair, I already have a public key here, so I'm going to use the one I have. But in your case, if you don't have one, you can simply click on create new key pair to create a new one for yourself. And also for the networking side, I'm going to click here, and I'm going to switch over to my VPC, and the subnet, I want to deploy it. Okay. So we have private subnet, public subnet 1, and also another public subnet. So let's just launch it in US East 1B. Now I need you to understand something, that if we launch these 3 instances, if we create these 3 instances at the same time, all of them are going to be running on one subnet and in the same availability zone, right? So it might be worth you, right, trying out some stuff, right? You can just simply launch one for each service and then try to, spread them across different AZs and different availability zones than just, launching them on the same subnet, right? And the reason is that, once you launch everything at the same time, you cannot change it once the instance is up and running. So you just have that at the back of your mind. I'm just doing this for a tutorial, right, for demo, so you understand how to do this. But in your own case, please try to do more experiments on how to spread it across. So we have that firewall. So let's say the security groups, we already have security groups. So let's click on existing security groups and select the one we created. So we're going to select the front end security groups. And that is pretty much everything that we need to configure from the 𝗪cie𝘂'𝗋 side of view. And also we need to add the user data script, and we're just going to come here, copy this, which is going to run the entire script for us, and paste it here. And also we need one more, and which is to install the Docker, this one here. So click on copy and come back and add it. Now this is a bash script, right? We are trying to create some shell script that is going to get executed once the EC2 instance is up and running. But we also need to add, the shell interpreter, right, to tell the EC2 instance to use which interpreter. It can be bash, it can be ZH, it can be Python, but we are using bash, so we need to specify that here. So for that, we need to add the interpreter. So we're going to add the shell bank followed by the exclamation mark /bin/bash. Now this is going to tell the user data execution that please use this specific shell to execute all of these in a sequential manner. So it's going to get executed, right? So let's click on user data has already been no, we are not base 64 encoding it, so we're just going to leave it like this. So that's that, and let's click on launch instance and see. So let's click on launch instance. It's going to take just a few minutes. So as you can see, we have 3 EC2 instances being launched. And if we go to the console, we're going to see 3 of them on on the initializing state, which is quite good. So this is where we now need to customize it. So we can call this the Vote app, right? We can call this the Result app, and also we can call this the Worker app. Now once we've done that, we need to now start launching our instances, and you need to start connecting to those instances. So let's do that. So from here, let's grab the IP address of the front end. So if you come over here, you're going to see the front end. There's no public IP address attached. That's weird. Why is that? Let's see if they are running on a private subnet. Oh, I think we made a mistake. They are running on private subnet, which is what we don't want. So we've made a mistake here. All of them are running on a private subnet. So because of that, they don't have private IP. They don't have public IP attached to it. You've got just private IP. Now, how do we do this? How do we connect to this instance? So the only way for us to connect to this instance is to create a bastion host on the public subnet, and then from the bastion host we can now start connecting to those servers one after the other. So do we do that, or should we just go and destroy everything and create it from the scratch, right? So let's destroy it and then let's create everything from the scratch. So click on terminate instances. Let's terminate all and let's launch a new one. I did it on purpose so you can learn something, that when you create an EC2 instance on a private subnet, it doesn't have a public IP attached to it. So let's call this front end. I'm just going to be fast. Click on Ubuntu, leave that as it is. Select my key pair to be 𝗬𝗿. Come here, edit my VPC, select the one I created, and then put this into, you can see this is a public subnet. I'm going to leave it, put it in a public subnet. Then enable auto assign public IP, leave that. Existing security groups, click on front end and go straight to the user data script and paste the script, paste it and paste the last one, which is going to install the Docker engine and the Docker daemon on the machine. So go down, install it, and also we need to specify the shell bank. And that's it, and let's launch the instance. So let's go back and see if we've got. So let's go to the ones that are running. Click on the front end and let's rename this to be the Vote app, and let's call this result app, and let's call this worker app. Save it. I think this didn't work, so let's go back and call it Vote app. So these are the three instances, and let's log in into the three of them. So let's go to the first one, grab the IP address here and head over to your terminal. So I'm going to be using this terminal, which is called WAP. If you like it, you can go check it out. So let's go to my home directory, and I'm going to head over to the directory where my private key is, which is downloads, and this is where I'm going to connect directly to my EC2 instance. So in order for you to connect, you need to run the SSH-I, specify your private key. My one is called 𝗬𝗿.pem, and then followed by the user. So the default user that comes with Ubuntu when you provision an EC2 instance is called Ubuntu. So I'm going to specify the username there, which is Ubuntu, then followed by the IP address of the machine. So I'm going to hit enter, wait for a few seconds. It's going to prompt me to agree. I'm going to say yes and hit enter. So we have permission denied here. So what is the issue? Let's go back. Let me see if I have the key here. Let me search for the key if I've got it here. 𝗬𝗿.pem and hit enter. Oh, we don't have that key. That's a huge mess. Let's head over to AWS, and I think so. Let's see if we have we've got the key here, the e-voting key. Yeah, we've got the key here. That means it should work. So let's go back and retry. So if you come back here and let's retry again. I think we might have, let's see. Okay, I think we need to grant permission. So let's say /mod. Let's give it 400 permission and followed by evote.pem, and yep. So let's clear our screen again and try to log in. Yep. Let's try to log in. Let's try to log in. I think let's start with this one. Let's start with the new. It's basically the same IP. So let's hit enter and let's say yes again and hit enter. Wait for some time. Yep. So we are logged in into the new, we are logged in here. As you can see, this is Ubuntu IP address. And in order for us to identify this machine, across all the servers, we can simply change the name to the specific application. So let's call this host. Let's do sudo host name ctl set host name. Let's give it a name. Let's call this let's go back again and see which of the application it is, the voting application. So let's go back and call it vote. Let's just call it vote and hit enter. And then let's see if Docker is installed. Let's do Docker ps. Oh, Docker command not found. That means our shell script didn't work. So we need to manually do that by ourselves. So let's clear our screen. And in order for us to install Docker, let's go back again to the Docker website and copy the commands. Go back here and then paste all the commands and hit enter. So while that is running, let's go grab the last command here, which is this, and go back and wait. So this is done. So let's install all the Docker components. Hit yes, and it should be fine. So wait for some few seconds, for some few minutes to get that up and running. So that is installed. Let's run Docker ps now to see if. So in this case, Docker is installed, but we are having permission denied error. Now, how do we go around this? So by default, Docker has, in order for you to run a Docker command, you need to be in the Docker user or be in the Docker group. So we need to add our user. So our current user is Ubuntu. So we're going to add Ubuntu to the Docker group. So how do you do that? It's called sudo user mod, like this, user mod, followed by the group. So we call this add is user mod a and followed by g group. And then what is the name of the group? The name of the group is Docker, followed by the user you want to add, which is Ubuntu, and hit enter. So that has been added, and in order for everything to take effect, you need to log out from the machine and then re-log in again back. Yeah, so everything looks good. So let's clear our screen. So let's run Docker ps again to see if everything is working. As you can see, oh, Docker ps, Docker not installed. Okay, sorry, Docker. That was a typo. So yeah, so you can see our Docker command is running. There's no container running on the server. And also, you see that immediately we log out of this machine, the host name changed to vote, right? That's because when you change the host name, you need to log out from the machine or from the server and then re-log in order for you to see that effect. So when I log out, everything went back to the same and everything looks good. So let's clear our screen. So this is our voting application. Now let's log in into the other. So let's log in. First of all, let's go to the directory where the private key is. So it's going to call cd downloads. and hit enter, and then this is where we can now log in. So SSH, yep. Bottle suggestion is already giving us, yep. So I think I followed by the 𝗬𝗏.pem, Ubuntu, then the IP address. So let's go and grab the IP address. So let's grab the IP address. So the IP address for the worker is this. Head over back. Go back, and then hit enter. Gonna say yes, and should be fine. Yep, so we're in. So let's first of all change the host name, which is sudo host name cts set host name. Let's call this the result, right? Is it the result application or the worker? Let's have a look. Okay, it's called the worker app. So let's call this worker and hit enter. Now, just to remind you, as you can see, we've changed the name, but this is still showing this random name, which is like the IP followed by the private IP address. I'm going to leave that, and let's install Docker. Go back again, copy the Docker commands, go back here and paste it, hit enter. While this is downloading, let's go back again and copy the last command, which is this, and go back and then install that. While this is running, let's log into the last instance to configure it. So the last one is the result EC2. So grab the IP address, go back again. First of all, go to directory, which is the downloads. So the reason why I always come to this directory is because my private key is always here whenever I download a new SSH private key. So we're going to call this 𝗬𝗏.pem, then Ubuntu, followed by the IP address. Yes, hit enter. Sorry, I need to do that again. Gonna specify yes. Oof, public key permission denied. Yeah, I think I made there's a typo. This is voting. Yeah, so I'm logged in. So let's go back and see if this is completed. Yeah, so this is completed. In order for us to complete everything, we need to add the Ubuntu user to the Docker group. So sudo c user mod a group is Docker, followed by what? The Ubuntu user. So that's it. We'll log out and relog in again for everything to take effect. Yep. And now if we run docker ps to see if Docker command is working. Yep, everything looks good. Now we're done with these two, the votes and the worker. So let's go back to the last one. So the first thing we need to do in the last one is to also change the username. Let's just grab the command from here on how to change the username so we don't waste more time. So this is the command. Let's grab it here, paste it, and change it to result. Change it to result. And hit enter. And also we need to install the Docker commands that we have here. Come here, copy them, go back, and paste everything here, hit enter, go back again, copy the last command, should take paste again, hit enter, and then the last command, which is going to add Docker to the group. So I'm still going to copy that from the worker application. Anyways, let's just leave that. Let's run that manually. So the last one is sudo user mod docker ubuntu like this, and hit enter. So everything looks good. Now let's exit and relog in again to see if everything is fine. Good. So now we've succeeded in launching into the EC2 instance and also changing the host name. So we've got the vote, worker, and result application set up. So we have our 3 applications servers up and running. We've got the worker, the vote application, which is running on its own separate server. We've got the worker running on its own server, and the result application running on its own server. Now it is time for us to now create the 2 servers for our backend, which is our database for Postgres and Redis. If we go back to the architectural diagram for the applications, we see that we've deployed these 3, which is the voting app. We've deployed the server for the voting app. We deployed the server for the result application. We've also deployed the server for the worker application. Now what is left for us to do is to deploy the one for the 𝗪𝗪𝗂'𝗋₃ and also for the Redis, and also for the RDS. Now in the later stage of the video, we are going to be using AWS native services like 𝗪𝗪𝗂'𝗃 and AWS RDS. Now these are software as a service, or they are managed service provided by AWS, so we don't need to manage the overhead of patching and running these kinds of sensitive backend services like Redis and Postgres. But for this demo, which is the first architecture of this project, we are going to be deploying them on a server using Docker containers. So we're going to be deploying the Redis container inside a separate server, and also the Postgres container inside a separate server. And these 2 backend database, they are going to be running on a private subnet and not on the public subnet, which these 3 servers are already running on. So let's go to our AWS console. Now head over to your AWS console and let's create those 2 instances. So come over to the launch instance and come here. Let's call this, let's give it Postgres. Let's deploy the one for Postgres, and come to Ubuntu, click on Ubuntu. We're going to be using Ubuntu server to deploy that, and let's leave it as default for free tier so we don't get charged too much. I think this should be all right. Just 1 container. So in the key, we already have a key, which is evolt. So click on the key, and to the network settings, now you need to select our VPC, which is the evoting VPC. And on the subnet, we're going to be deploying it on a private subnet. So you can deploy it here or any available private subnet. So in this case, I will go with evoting subnet private 1, US East 1A. So I'm going to use that. And then security group. Now, I think we already have backend security group, so let's use that. We already have a separate security group at the beginning of this video when we created a security group. So let's use that. And also, the user data script, we've tried it before, but it didn't work. I think I missed something, but let's do everything manually. At least it's going to help you to understand how to do this. So a number of instances, we're going to spin up one and create, let's launch instances. So that's for the Postgres. So while we wait for the Postgres, let's launch another one for Redis. So let's go back, click on launch instance. Let's call this Redis. So this is going to be our Redis. Let's choose a Linux machine and leave that as default. And the key pair, we're going to be using our eVoting key pair as usual. So let's come here, click edit, and let's go to eVoting VPC. The subnet, the Postgres is already running on US East 1A. Now let's put the Redis on a different subnet. So let's come over here to subnet private 2 US East. So let's use this one, which is US East 1B on the private network. Let's scroll down, select existing security group. So let's go back and select the backend, and that's it. Scroll down. I think that's pretty much it, and click on launch instance. Now let's go back to our EC2 console. We should have those two applications running. So let's go down and see what we have here. So we've got Redis and the Postgres application running, right? So we've got them. Now let's connect to these two instances. Now we can't connect, so we're going to be using one of these applications, one of these servers to, or one of the EC2 instances to connect to either Redis or Postgres. So let's do that. Head over to our share. Now we have the vote, the worker, and the result. Now, which of them do you want us to choose? Well, let's go. Let's use the voting server as the bastion host to connect to those two servers running on the private network. And in order for us to do this, we need the private key, right? We need the private key of we need the eVoting.pem private key, and we don't have it here on this server. So what I'm going to do is that I'm going to copy it over from my local machine into the eVoting application, and from here we can now connect to those servers. Now, before I do that, let me create a separate directory. Let's call this key on the server, so I know where to put my key and also how to connect to the two Redis and Postgres. So let's call this key. And yeah, so we have the directory called key. Now let's exit from the server, from the Ubuntu voting application server. So let's exit. So I'm already on my local machine. As you can see, connection to 33 has been closed. So I'm out of this this EC2 instance. I'm already on my local computer. Now if I do ls eVoting.pem like this, you can see that this is the key. This is the private key. So I'm going to copy this into my local machine. Into the EC2 instance. Now, how do we do that? Now, there's a special copy. There's a special SSH copy command called SCP. So we're going to call it SCP like this. It's going to be SCP, and it's going to be followed. We need to specify the key. So the key is going to be -i followed by the key name, which is eVoting evote.pem, followed by the file we want to copy. The file is evote.pem, and then followed by the login, the username of the machine, which is Ubuntu, followed by the IP address, and this is the IP address. You can grab it from here, copy and paste like this. So hit enter. So let's see if that works. So we've copied the command over to the server. I think we should have like a message here telling us that worked. Okay, I think that command didn't work. So let's go back. Let's rerun the command. I think I made a mistake. So the command should be evote scp-i. -i tells us the key to log into the machine, and also followed by the key that we want to copy, then followed by Ubuntu at the name of the server. And also we need to specify a location on the host where we want to copy the key over to. So it's going to be /home/ubuntu user ubuntu / the directory we created, which is key. I think it should be here, and let's hit enter. Yeah, as you can see, the key has been copied successfully to the server, 100%. So we now have the key on the server. Now let's log in back to the server and see if we have the key there. So let's go back again. It's gonna be this SSH. Yeah, that's my previous command. So it's gonna be this, and let's hit enter. Yep. So we are in. Let's clear the screen. Now let's do ls. Yep. As you can see, we have the key here, right? We have the key. Sorry, we need to log into the key and do ls. Now we have the 𝗬voting.pem key here. Now it is from here, from this directory of the key, that is where we can SSH into those two servers. Now let's grab the one for the Postgres and let's log in into Postgres. So let's grab the IP address of Postgres. So this is the IP address. So this is Postgres. We're going to copy the private IP, which is this 10.16.30.174. Copy that and go back to the terminal. Oh, sorry about that. Go back to the terminal and then let's connect. So it's going to be SSH-I, which is 𝗬voting.pem Ubuntu at. Now paste the private IP. Now you need to also understand something like if you go back to the console, right? If we go back to the console like this, you notice that the Postgres instance does not have a public IP address. Now, which tells you that this Postgres or this server is not accessible. It's not accessible over the internet. You can only access it on a private network by using those servers running privately, which is either of these applications. Sorry, either of this EC2 instance. And also, if you come here again and click on the Redis, you will see the same thing. But other than that, if you click on any of the application, you see that they have a public address, which means you can access it over the internet. So let's go back again to the terminal and see if we can connect from one of those servers. Let's hit enter. So it seems we are having issues trying to connect. I think the security group might be blocking access from these servers. So now let's go back to our security group and inspect if we allowed connection over, if we allow connection over the SSH, which is port 22 on those backends. So let's go back and inspect the security group of Postgres. So let's come here, go to the security groups. Go to the security groups and scroll down. Click on security groups and let's see what we have. As you can see, there's no inbound rule at all, which means that even if they are on the same network and there's no rule that allows those connections is going to fail, right? So let's edit inbound rule. Let's add some rules to the backend. Now what we're going to do is that we're going to allow all connection from those backend service. So let's scroll down. Which is the backend security groups. Now, what this means is that any instance that is running on the backend security group have access to the database. Of course, that's what we want. We want our backend applications or our applications to be able to connect to the database to retrieve data and all of that. So let's click that and save rule. Now, if you save this rule, if you go back, you see that this connection is going to work. Now it's still not working. Let's cancel the command and let's start again. Let's rerun the command. Yep. And hit enter. Still having issues? What could that be? So we can't still connect. Let's go back again and check the rules. So let's go back again. So have one rule. Let's inspect this one more time. So what we did was that we allowed connection from within itself, which is the security group the backend security group itself, we are supposed to allow connection from the front end security group. So let's change that and save rule. Now let's go back again and connect. Now if we go back and connect to see if that's going to work and hit enter. Yeah, so that worked. So yeah, yes, and hit enter. Yep, so we are connected. We are connected to the Postgres. So what do we do next? Let's change the host name for Postgres. So let's change the host name. How do we do that? It's going to be host name. Why is that going up? So let's call it host name. Let's add the sudo command to it. So sudo host name. Hostname ctl set hostname Postgres. Let's hit enter. Command not found. Host name, I think we misspell it, ctl, and hit enter. Now also we also need to install Docker, right? We also need to install Docker. Now let's head over to our browser and get those and grab those Docker commands. So Docker installation for Ubuntu. The first one here is going to give us the command we need here. So let's grab the commands. First of all, let's copy this. Let's copy this command. Come over here to, now this is where we're going to know if these private applications are working. Sorry, if this backend or these private subnets have access to the internet by using a gateway. Now, if this command doesn't work, that means we have issues with our connectivity within the VPC. So let's try it and hit enter. Good. So we can connect. That doesn't look good. That doesn't look good at all. That doesn't look good. So it seems like we are having issues trying to connect to the internet from the private network. So we're going to go back and inspect what the problem is. Oh, it looks everything is working. So let's wait for some few minutes. Let's wait for a few seconds to see if that's going to work. Wow. So it does mean, so we're having connection timeout here. You can see connection timeout could not connect to security Ubuntu, which means we have issues trying to reach to the internet. Now let's see. Let's try another command to see if we have internet access. Let's do ping google.com. Yeah, we have issues, so we can't connect to the internet. That's a now let's go back to our VPC to inspect what the problem is. Now let's go back to our security group to see if everything is right. But before then, let's just go over to our VPC to ensure that everything is working fine. So let's go to VPC and see that we have all the routes properly configured. And if we click on our VPC, let's see how everything is being routed. And let's see. So the Postgres instance is running on US East 1A on the private subnet, and we can see that it has a route table that routes directly to the NAT gateway, which means we have internet connectivity. So we can see that the issue is not from the VPC or from the NAT gateway. So let's go back to our security groups and have a look. Now let's go to our instance and check the security group properly to see if everything is correct. Now click on the backend security groups, and from here let's have a look at the outbound traffic, outbound rules. Oh yeah, this is the problem. So if you look at the outbound rule, it is allowing outgoing connection to another security group, which is not the current route, rule. So we're going to delete this rule and add a rule that allows all connection to the internet. And we're going to specify outside that block and save rule. I think this should do the magic. Now let's go back. Clear the screen. Clear. Why is that? So let's do ping again to see if it's going to connect. Ping google.com. Yep. So everything looks good now. So let's stop that. And let's go over to the Docker command, copy, and let's paste here to install Docker. So as you can see, the installation is going well. Everything looks good. Yeah, I think this is going to work. It's going to work just fine. While we are waiting for that to be ready, let's go back to there and grab the last command here and paste and hit enter. Go back again, copy the last command that is going to install the Docker and the Docker compose for us. Go back and do that. Yep. Yeah, we're going to accept that. Wait for a few minutes for that to be ready. So while we're waiting for this to be ready, let's connect to the Redis instance as well. So we are connected to Postgres, Worker, and Result. And remember that it was from this shell that from the Vote application, we connected to the Postgres. So we also need to, in order for us to connect to the Redis as well, we also need to first connect to the voting server EC2 instance and then connect to Redis, because Redis is on a private subnet. So let's do that. So let's head over back to the terminal and go back to our EC2 instance. Go back to EC2 instance, click on EC2 instance and scroll down. Go back to the result application. I think the vote, is it the vote or result application? So it's the vote application. So let's come here, grab the IP address, go back again, and let's connect. So SSH, yeah, so change the IP address, hit enter. Yep, so I think I know what the issue. You need to go over to the downloads folder and then we run the commands and hit enter. So we are inside the voting application. Now this is the only way for us to connect to those private subnets. So let's go back to the /key directory, and then this is where we can connect to Redis. So let's grab Redis IP, grab the Redis private IP, go back again and connect. So we're going to connect like this again. I'll paste the IP address of Redis. Yes. So we are connected to Redis. So again, sudo hostname cts set hostname to Redis. Set hostname to Redis. And now let's install Docker. I'm gonna install Docker. So let's copy all the command here, paste everything here, hit enter. While we're waiting for that, let's grab the last command again. Now we install the Docker daemon, and this command is going to install the Docker daemon and everything. So click on it and go back again. And yep, yes. So while we're waiting for this to be ready, let's go back to the Postgres instance. So we have Postgres here. We've installed Docker on it. But if we run the Docker command, it's going to throw us an error like this. So we need to add the Ubuntu user to the Docker group. So how do we do that? Now we're going to run sudo user mod and -a followed by g. The group we want to add the user to is Docker, and then the name of the user is Ubuntu. So the reason why we're doing this is because we are running as user Ubuntu, and user Ubuntu, is not in the Docker group. And in order for you to run Docker commands, you need to either be the Docker user or you need to be in the Docker group. So if you also run Docker PS now, it's not going to work. You need to log out from the machine and re-log in again to be able to access that. So if we log in again and run Docker PS, you can see that we now have access to Docker commands. Now let's go to our Redis. Redis has been installed, and in order for us to see the Redis host name, we need to log out from the machine and also re-log in. But before that, let's also add the Ubuntu user to the Docker group here. So we're gonna do sudo user mod and then -a followed by g. The name of the group is Docker and the user is Ubuntu, like this. Now if we exit now and re-log in like this, so if we do Docker PS Docker PS like this, you can see that we have access to the Docker command. Good. So far we have the Postgres, the Redis, the worker, the result. We have the worker as well. Let's clear the screen to have a clear screen. And also we've got the result application, the result server or EC2 instance. So as you can see, we now have all 4 instances. The last one, let's open the result application here so we can have everything on one tab. So the vote, copy it and go back. And let's SSH into the voting application. Voting, okay, cool. So we now have all the 5 microservice servers up and running. Now, since we now have the server, the next thing for us to do is to now deploy our applications as Docker containers inside each application. Now, how do we do that? Now, if you head over to the repo like this, if you head over to the e-voting application, if you go back to the Docker compose file, you're going to see that this Docker compose file deploys everything, right? It deploys everything at once inside one server, right? But in this case, we don't want to do that. We want to deploy each application, right? For instance, like the voting application, the vote application here, we want to deploy it on one server. The result application, we want to deploy it on this server. And the port application, the worker application on this own server, and the result application on this own server, DB on this own server. And we don't need this, we're going to get rid of that. So these are the only applications that we need, right? So we need to separate all of these out on their own on the Docker compose file and deploy them individually inside we need to deploy them individually inside the separate server. Now let's copy that and go back to, let's go to VS Code. I'm going to create a new tab here in the VS Code. I'm going to close that. And this is where we need to make the changes. So let's scroll to the top. So for the vote application here, we're going to leave it as it is. And we're going to separate it out like this. which tells us that this one is a separate YAML for the voting application. Then also, we also need that as well. We're going to call this service hyphen. Now, this is going to tell us that this application is a different Docker compose with a spot. So we're going to do for the worker as well. We're going to call this services. Is it service or services? Oh, services, sorry. So we need to call this services. This is going to be service. Then let's add the !, which is going to tell us that this is another Docker compose. And for the Redis, we're still going to do the same. We're going to call services. And we also need to add the !, which we tell that this is a different Docker compose file. And then the last one for the DB service, I'm going to call this services. Now this is for the DB service, and we don't need this. Let's get rid of that. And also, we need volumes for the data, for the DB data and the Redis data, right? So if you come to the DB data here, we come to the DB data volume section, we're going to leave that as it is. We don't need this network, get rid of that. Then we also need the Redis data copy and go back to the Redis and add a volume there. Yeah, so we're going to call it Redis data. I think that's pretty much everything we need. Just going to run through what I did here. So what I did essentially here is we have the Docker compose file that deploys everything at once, like all the components into one server. But since we are now breaking it down into different microservices, we need a way to separate them out into different and individual Docker compose so we can run them each individually on their separate server. So this is the first one. This is the voting. This is the vote application. And this is the result application. Is on Docker compose. So let's remove this network. We don't need this network session since it's running on a separate server. And also, this is the service application, and this is the worker application, and this is the Redis application, and this is the DB application. So we have all of them separated out, and now let's copy each Docker compose into the different server, different EC2 instance. So let's do that. So let's go to the application itself. I'm going to leave the application, this link, I'm going to leave it in the description. And scroll down, we're going to clone it, go back to SSH, clone, and over HTTPS, click on that and go back to the each server. So let's come here. For the Postgres, we're going to clone git clone, and that's going to clone the repository. Let's go back to the Redis git clone. Gonna clone that as well. To the worker git clone. Essentially, we're trying to download the repository that contains the source code into those virtual machines, into the EC2 instance. And let's do here git clone. Yep. Okay, so we already have e-voting application here. Yeah. E-voting application here to the worker. E-voting application to the Redis. E-voting application to the Postgres. E-voting application. Good. So we connected to the private and also to the public as well. So let's clear the screen again. Clear your screen. here, clear the screen now. Let's edit them one after the other. Let's start with the the result application. Now in the result application, let's clear our screen. So we have the e-voting folder. So go back to the e-voting folder and hit enter and do ls. You're gonna see all the command. Now what we are concerned about are two things, right? The first one is Docker Compose. Now if you come over to the Docker Compose, we still have the old Docker Compose files here. So we need to get rid of all of these. So let's get rid of everything. We don't need it because we are not deploying everything on one EC2 instance. We are deploying it separately on individual EC2 instance. So let's clear that. I think the best way for us to clear that without wasting our time is just to run this arrow like this, followed by the Docker Compose. Now this is going to give us an empty Docker Compose file. So let's go back again. As you can see, it's empty. Now go back to your VS Code and copy the vote Docker Compose. Copy it like this and go back and paste it here. So this should work. And now if we run Docker, let's do ls and clear the screen so we have it here. Now since we now have the application, the Docker Compose run, we can now run Docker Compose up. So let's run Docker Compose up -d. So the Docker Compose up is going to bring up the container, it's going to build it and package, it's going to build it and then start running the application. And the -d is going to run it, on the background. So let's run Docker Compose up and let's wait. As you can see, it's throwing us an error that there are some variables that need to be passed in, right? So we need those variables. So as you can see, we need the Redis host and also some other variables. Now let's go back again and have a look at the Docker Compose file. Now if you have a look at it, if you have a critical look at the Docker Compose file, we need the Redis host as an environmental variable. Now since this Redis host is not there, it's going to throw us an error because we need this environmental variable. Now how do we pass in the environmental variable for this? Now, this is what we need to do using 𝗪𝗵𝗿. Now, let's go back. Now, what we need the host name for Redis and Postgres because these front-end applications needs to connect. Now, if you go back to the architectural diagram here, you see that the voting application needs to connect to the Redis instance. And because of that, it needs the Redis instance IP address or the host name. In this case, we're going to be using 𝗪𝗵𝗿. Now, if you go back to your AWS console, type for 𝗪𝗵𝗿. Click on it. We're going to create private zones. So let's come here and click on hosted zones. I've already created one, but in this demo, let me just delete this and let me create a new one for the case of this demo so you understand. So let's create new hosted zone, or let's just leave it. Let's create new one, hosted zone. Let's call this, it's going to be a private hosted zone. Let's call it evote, or let's just call it Barillon. Let's call it Barillon. And leave it as it is. It's going to be a private hosted zone. And also the VPC, we're going to select a VPC. So let's select for the region, we're going to be using US East 1, not Virginia. I'm going to select the VPC. We're going to select our VPC, the one we created. What is a private hosted zone? Private hosted zone means that whatever resolution, whatever DNS name you're going to be having on this hosted zone is going to be resolved internally and not externally. So let's use that. The reason why I'm using this is because I don't want to hard code the IP address. I want to be able to resolve using the hosted zone name. Now let's create hosted zone. It's going to take a while. Now let's create records on the hosted zone. The first one is going to be for our Redis. Redis, we're going to create a simple A record. And for the IP address, let's grab the IP address of the Redis instance. So let's come here, click on Redis, and grab the private IP address. Go back to 𝗪𝗵𝗿 and add the IP address here. So record is going to be, let's add the record. I'm going to create a second one again. Create record. Okay, there are 2 records. So let's create the second one for Postgres, and let's grab the IP address for Postgres. So come over to Postgres, grab the IP. Come here, sorry. Yeah, so have the 2 and then create record. Now you can see now we now have the 2 record here, Postgres.𝗪𝗏, Redis.𝗪𝗏, which means that if you want to connect to Postgres or Redis, we just simply reference the host name. So let's copy the host name and go back to let's go back to the server on the Redis on the Docker Compose. Now, how do we pass in environmental variables, right? How do we pass in environmental variables to Docker Compose? Where we do this by using a .env file. So if we run, let's create the .env file. We'll create it with tosh.env, and then let's .env, and then hit enter. So we're going to set the variable, the environmental variable, to which is our Redis. So we're going to call this Redis host, which is equal to the Redis.𝗪𝗏. So that is all we need. Hit enter. Like this, and then let's clear the screen and now run Docker Compose up again and see if that's going to work. So let's run Docker PS to see if we have the application running. As you can see, the application is not running. We're still having issues. Now let's run Docker PS-A to see what the problem is. Let's see. Oh yes, I found the problem. So these 2 networks, we don't need them here because we are running them on a separate network, on a separate server, so we don't need them. So let's clear the screen again and run Docker Compose up. Let's see. And also, we're still having issues again. It says service vote depends on Redis. So we also need to remove the dependencies because obviously we are not still running it on the same server. So let's remove that dependency. Go back again. So Redis depend on Redis. We're going to remove these. I'm going to remove that. So we now have a clean Docker Compose file, and then run Docker Compose up again. Yep, so this is going to work. So wait for some few seconds to have that up and running. While we are waiting for this, let's head over to Redis. So this is Redis instance, or let's head over to the Vote application itself. So in the Vote application, let's go into the directory and we're going to edit the Docker Compose file as well. So we're going to empty it by redirecting an empty content into it, and then let's go into so we're going to copy the result application. So we're going to copy this and paste it. Now we need to make some modification as well. So let's go to the top. So what do we need to do? We need to remove this depend on. So we need to remove that. Yeah, so the volumes, everything looks good, the port. And then we need to pass in these variables, right? We need these variables in order for us to run the result application. Now, how do we do that? We need to create those 5: Postgres user, Postgres password, Postgres host, and Postgres DB. Now, how do we do that? So we can do that by creating the .env file again, tosh.env, and then going into the .env file. So we need to pass in those variables. So let's go back to the VS Code to make that edit and then copy and paste. So if you come here, these are the variables that we need, right? So let's try to modify them and then copy over and paste. So we need the Postgres user, Postgres password. We also need the Postgres host, and also we also need the Postgres DB. So let's go after that. Let's do this one after the other. So let's come here for the Postgres user. We can call this 𝗬𝗿, or we can call it Postgres. And for the password, you can just give it any password you want. So this one, we're just going to call it 𝗪𝗿 as a password. Then for the host, the Postgres host, so if you come over here to the Postgres host, on the Route 53, it is called Postgres 𝗪𝗿. Let's copy that, go back, and paste that. Paste that. And the database is going to be vote. Now this is all we need. This is all we need for that. Remember that we are yet to deploy we are yet to provision the database, the Postgres instance. So let's copy this, go back to the server itself and paste it here as the content, and then save. Now once you save this, you can now run your Docker Compose up. Now if you run Docker Compose up -d, you're gonna wait, it's gonna build the application. Now while we're waiting, let's provision our database. In order for us to do that, we also need to go back to I thought we run git clone inside the Postgres, so we've not cloned the repository inside the Postgres. So let's go and grab this, go back to Postgres and git clone and clone it. So if you run ls like this, we should have it running here. So let's cd into that ls, and then we're gonna to make it empty. Then we're gonna log in again. Let's go back to VS Code to grab Postgres, which is our database. So we're gonna grab it like this, copy. Gonna paste. You need to paste. So this is our database, and we also need to pass in these variables as well. And we need to remove this network. We don't need that. Yeah. And this is all we need. And we also need those variables as well. Remember that these variables must be the same as the one you are passing into Postgres. Otherwise, those applications we won't be able to connect to Postgres. So let's create our 𝗪𝗵.𝗪𝗵 file. So paste that here, and now let's run Docker Compose up -d to bring up Postgres. So while while we're waiting for Postgres to be ready, now let's go to ready. So I think Postgres is ready. That was fast. Yeah. So Postgres is up and running. So good. So Postgres is up. Let's check the result application PS. Result application is up. So we have that running. The voting application. Let's run Docker PS. Yes, the application is up. So we have 3 applications working. So we need just Redis and the worker. Now let's start with Redis, right? So let's run ls and follow the same procedure, cd into that ls. So let's grab this and let's empty it. Let's pass in an empty file into it and then vim into it. So let's go back to the VS Code, grab Redis. So grab Redis like this, copy, go back and paste. So let's see if we need to make any change. We need to remove the network tier. Yeah, so we're gonna leave it like this. What do we need? Do we need an environmental variable? No, we don't need any environmental variable for Redis. So let's say I run docker compose of -d. So volume not allowed. I think we made some. Let's go back again. So this is volumes and not volume. This is volumes. So let's run docker compose up again. So that's going to spin up Redis, and let's go to the worker. Let's head over to the worker. So copy that. Okay, so let's check what we have here. So this is the e-voting. This is where we need to be in. So let's do cd follow there, and if we run ls, we need to edit this again. So let's redirect that there. I'm going to redirect into this folder, and then let's do vim there and hit enter. Now let's go back to the VS Code again and copy the worker. Where is the worker? So that's it. So this is the worker docker compose like this. Copy and go back. Paste it here. Now you can see that in the worker docker compose, we need almost all the variables, all the environmental variables here. We need almost everything. So what we need to do is to remove the dependencies first. You need to remove the dependencies and all of that. And you also need to remove the docker tier. And what we need is these variables and how to parse them. So if you look at the variables, is we have one more compared to the one we already have. So we need the Redis host. So let's go back. So we need to create the .env file. We need to create that, and let's paste the variable we have. These are the ones we have currently. We just need to paste them. Go back to here, paste them, and also we need the Redis host. So let's do Redis host, and the Redis host is redis.barillon like this. So now let's run docker compose up -d. Now, so we now have everything building from the scratch. Now we need to validate if there's connectivity, if the worker can connect to the database, if the result application can also connect to the database. Now, so let's start with the eVote. Let's start with the voting application, and let's check the logs. Let's see if it can connect to Redis. Docker logs, copy like this. So it is running, but we are not sure if it is if it connects to the Redis instance and to the result application, which is the vote. Yeah, this is the vote. This is the result. I think we made a mistake. We deployed the voting application inside the result, and we deployed the voting application inside the result application. Anyways, let's just leave it like that, right? So let's go back to this one. Let's clear the screen, Docker PS again, and let's check the logs. So Docker logs and to see. So you can see that this is currently waiting for the database to be up. It can't connect to the database for some reason. And let's try to ping if you can get the database IP from this machine. So let's do ping postgres.𝗪𝗏. Yeah, as you can see, we can't connect. So what is the problem? Let's restart the container because I think when we deployed this, the database was not ready yet. So let's restart to see. See? Yeah. So let's see. So we're still having issues. It's still having issues trying to connect to the database. So let's stop that. We're still having issues trying to connect to database. So let's go back to the security group. Let's go to the security group of the Postgres. So if you go to Postgres security group, come over to Postgres and security group, click on the security group and see we are allowing all traffic from the front end, so that should work. Okay, let's allow all traffic. Backend security group, let's say allow all traffic from the front end security group, and let's save that rule. Now let's try again if that's gonna work. Come here, clear the screen, and Docker Compose build again. Let's see. Still not working. So apparently we are still getting issues waiting for DB, which means there's something wrong with our database. So let's switch over to the Postgres to see what is wrong. And what is wrong with Postgres? Okay, this is the issue. So you can see that Postgres is exposed. It's not exposed externally, which means that we can't connect. So it is only exposed. It's only telling us the port. It's only telling us the port where Postgres is running locally. So we need to expose this port in order for Postgres to be accessed by external service. Now, if you go back to the Docker Compose file, if you do ls, go back to the Docker Compose file, and so we're going to attach a port here to expose the DB to external traffic. So I'm going to add that to the Docker Compose. Going to call this port, and we're going to map it. So I'm going to call Postgres is running on 5432. I'm going to map it to 5432. So that is set, and let's Docker Compose up again. So Docker Compose up minus d-d then # build. Let's rerun that. So let's do Docker PS. Yeah, so as you can see, it is now exposed externally so that we can access it. Now let's go back to the application again and restart. So let's do Docker restart voting result. Let's restart it. So let's do Docker PS again to see. So it has been restarted 4 seconds ago. Now let's check the logs again if we can if you're still having issues. So yeah, so it is connected to the database. That's a good sign. So it's connected to the DB, which is good. So we are done with voting. So voting connects to the database. However, we are still having issues with the votes, the vote table. So we don't need to worry about that. We are just concerned about to see if it can connect to the database, which is good. Now let's head over to the Worker application. Let's do Docker PS. And let's restart again. So gonna be Docker compose -- build to restart it and see. Okay, that's good. Now let's Docker PS to see if the Worker application is working fine. So let's do Docker logs followed by this. So we can see we're having issue trying to connect to Redis. So it's connected to the database, which is good, but it is still trying to connect to Redis, which means Redis has issue. So let's go to Redis. Now, what is the problem with Redis? Let's clear our screen to make it. So Docker PS. Okay, Redis is exposed within the server itself, which means it can't be accessed from external application. So we also need to change that. So if we come over to vim docker compose.yaml, no, not YAML, is EML. So we need to change this to bind to all port. So we need to change that here like this, and then docker compose up -d. Let's go again, and let's do Docker PS. Yeah, as you can see, it is exposed to all traffic, to all ports. Sorry, to all IPs, which means we can access it externally. So now let's go back again to the application and restart it. Let's do Docker restart, Docker compose restart, followed by the application. Let's copy the application ID, the container ID. Now let's restart. PS. Let's go. Gonna restart it. Docker restart. Let's see. Now let's do Docker PS to see restarted. Now let's check the logs again. Docker logs. Okay, found Redis, connected to Redis. Yeah, so it is connected. So we have successfully connected to Redis. So we now have the Postgres setup, Redis setup, Worker application setup, the the voting front end is set up, and also the result application. Everything looks good. Now let's access our application and see if we can cast our vote, and also we can see those things being logged into the application. So let's start with the voting application. So let's do Docker PS again to see. So this is the voting application, and it is exposed on port 80, which is marked port 8080 on the local host, which is port 8080 on the server, which is mapped to port 80 inside the container. Now let's connect to this. Now how do we connect? Go back to your console and head over to your instance and go to the voting application. Remember that we made a mistake. What we did was that we deployed the voting app inside the result application, and we deployed the result application inside the voting application. So since we want to vote, I think it should be inside the result application. So let's grab the public IP address and try to see if we can access the voting page. So it's running on port 8080, and let's hit enter. Now it's not going to work. Now let's go back again to the instance. We need to enable enable inbound traffic. So if you come to the security group, scroll down to the front end and edit inbound rules. let's say, so we allowed all traffic from anywhere on the front end. So this should work. This rule should have allowed that. So why is it not working? You sure this is port 8080? Let's go back to confirm the port. This is port 8080. And let's just confirm the IP address to see if we are using the correct IP address for 𝗪𝗵𝗁.me. So this is the correct IP address. Let's grab that on port 8080. Go back again. And I think I copied the wrong IP. So this is the IP. 𝗪𝗵𝗁. So we still can't connect. So what is the problem? Let's go back again. Inbound rule. Edit inbound rule. Security group, not that. Let's go back to the front end security group. Go back. And let's edit inbound rule. Let's say all traffic. Or let's say port 80. Or let's say all traffic. Or let's say custom port. Or let's just say all traffic. And then from my all traffic from my IP, you can use your IP. So let's hit save and let's go back again and refresh. This is still not working. So I think we are in the wrong traffic route, which is outbound. We don't need to touch this. Let's cancel that. Let's switch to inbound. Edit inbound rules. And let's allow custom TCP on port 8080 from our IP. You can use your IP and then save rule. Then let's go back and refresh. If that's going to work, boom. So that worked. So what we did was that we allowed security group. We added an entry for security groups to allow traffic from the custom TCP, which is port 8080. If you're having issues with your own, you can just simply grant all access or all traffic from your IP to all ports, right? So we have the the voting application running. Let's see if we can cast a vote. Yeah, everything is working. So we can cast our vote. You cast cats. It can be cat. It can be dogs. Everything is working very well. And the reason is because if you click here like this, you will see that this particular click, this vote has been stored in the Redis database. And from the Redis database, we can query the result application to get our result. Now, let's go to the result. Now, if you come here to the result, let's go to the result application here, which is running here. So if we do docker ps, we see that the result is open on port 8081. So let's grab the IP address. So how do we do that? We can use call for like this and 𝗪𝗵𝗁.me like this to get your public IP. So this is the IP address. So let's copy that, go back again on port 8081. So on port 8081, hit enter. Now this is not going to work as well. We need to add that to the security group. So let's go back to edit inbound rules. We can add more to 8081 like this. So it means it's going to work for both 8080 and 8081. So let's save the rule and go back again and refresh. Boom. So we now have the result application on the UI. Now let's see if we can cast our vote. Let's say we select docs. You will see that if you come here, you can see docs is 100%. And being that we are the only one currently voting, nobody else is voting, so it's going to be like this. like if you want to test this, if you want to test it and to make sure that it's working properly, you can share the application with different people, which means that you need to expose this across the internet. You can map it to a DNS name or whatever. But as you can see, the application is running. Now let's go back and check the logs to see what is actually happening within the application. Now, if you come to the worker application like this, if you do docker ps and to the worker application and you check the logs, right? So if you do docker logs like this, you will see that as we click on those buttons, those votes are being processed, right? It's being processed. It's going to pull it from Redis. It's going to process them and it's going to save them to the database. Now, if you come to the result application and you also run the same thing, if you run docker logs like this, you're also going to see the result application. You're going to see different errors. You're going to see connected to DB, and you can see some logs. Now, the reason why we are having these error logs is because we are trying to cast more than one vote, right? We are trying to cast more than one vote, and because of that, it's going to throw you an error. So this is the application. So this is how we can deploy the e-voting application on EC2 instance, running separately. It has been a very lengthy tutorial. And if you feel confused, some of the things does not make sense, you can simply leave them in the comment section below. And also, I'm going to leave a link to the repo and also to the Docker Compose file for each component. And also, I'll also leave some description that will help you when when doing this demo tutorial all by yourselves. So thank you guys for watching, and I will see you in the next one. Bye-bye.